Okay, today we are going to learn how to factor binomials. You can actually factor binomials just like you factor trinomials. The difference is you don't have a middle term. So when you go to do the step where you say what multiplies to this product but adds to this middle term, the middle number is 0. So it's kind of like if you thought about your problem like this. 9x squared, because there isn't a middle term. There's no linear term. So it's like having plus 0x minus 16. So we could still do the AC product. We could say, okay, 9 times negative 16. If we did that, 9 times negative 16 would give us a negative 144. The difference is we needed to add to 0 because obviously the terms must have canceled in order to not have a middle term there. So what two numbers multiply to negative 144 but add to 0? So that would be negative 12 and positive 12. And then we could rewrite this as 4 terms. We could say 9x squared minus 12x plus 12x minus 16. We draw our line right after the second term. So what do these two terms have in common here? They would have a 3x, and 9x squared divided by 3x is 3x, and 12x divided by 3x is 4. And of course, we'd still have that negative there. Remember, for those of you who like the grouping method, whenever this is a plus right here, we're going to pull that plus down. What number divides evenly into 12 and 16? What is their greatest common factor? And that would be 4. Again, think about it. What would you need to divide 12x by to still have 3x? Because we can do some foreshadowing here since we know we want that 3x minus 4 left. And negative 16 divided by positive 4 is negative 4. So we then take our two GCFs, the two outside terms that we've pulled out, 3x and positive 4, and we put our common group beside it, 3x minus 4. So I want you to take a second and look at this. What do you notice about these two binomials? Hopefully you can see they look exactly the same, except one is plus and one is minus. Whenever we're factoring binomials, we're going to look for a very special product called a difference of squares. For those of you who've been doing your lessons, you probably remember the difference of squares from the earlier part of our polynomial. Okay, so in order to get into difference of squares, what are square numbers? They are numbers with two equal factors. For example, 49 is a perfect square because it is 7 times 7. Or 9 is a perfect square because it's 3 times 3. 121, 11 times 11, or 169, 13 times 13. How can we tell if a variable is a perfect square? All we have to look for is if it has an even exponent. As long as the variable has an even exponent, it is a perfect square. For example, x squared is a perfect square because it is x times x. X to the 4th is a perfect square because it's x squared times x squared. X to the 6th is a perfect square because it's x cubed times x cubed. Remember, when we multiply like bases, we add the exponent. So that's why as long as the exponent is an even number, we know that the square root of it, all we would do is half that exponent. All right, so how to factor a binomial. First step, always factor out the GCF if possible. That's probably the biggest step students miss, but you always want to check and see, do the terms have something in common first? Then we're going to look for this difference of squares pattern. So what that means is we are looking for, do we have a term that is a perfect square minus a perfect square? It's got to have two parts. Is it a difference, and are both of the terms perfect squares? So if so, what we will do is we will create two sets of parentheses. We will put the square root of the first term in the front of each parenthesis, and we'll put the square root of the last term in the back of each parenthesis. And then we will make one of our parentheses positive and one negative. Look back at the original example we did. Notice we could have skipped all this work right here had we just recognized that this was a difference of perfect squares. The square root of 9x squared is 3x, so that's why we have a 3x in the front of each parenthesis. The square root of 16 is 4. That's why we have a 4 in the back of each parenthesis. And then one's plus and one's minus. All right, so before we get started with this, something that may be helpful is if you're not really sharp with your perfect squares, maybe go to the side of your paper and make a list of perfect squares. Just kind of go down, start with 1 squared, 2 squared, 3 squared, 4 squared. So I'm going to do that over to the side real quick. We know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169. And if we need to make our list longer, we will. These are the perfect square numbers we're looking for. All right, so for each of the first problems, all we are trying to do is determine if these binomials are a difference of perfect squares. That's it. We're not going to work them out. We're not going to factor them. Just are they a difference of perfect squares? So the first thing you want to look for is, are they a difference? Guys, if it's not subtraction, it's not going to work. So looking at the first one, it is a difference. Are both these terms a perfect square? Yes, because a squared has an even exponent and 9 is a perfect square. It's right here on our list. So for this one, it is a difference of squares. All right, what do you think about B? Hopefully you can see it is not, because immediately, because it has that plus there, it is not a difference of squares. It's really important that you make sure it's a difference. If it's a plus, we can't factor it. All right, what about C? So C is a difference, and 4 is a perfect square. We can see it right here. But the problem is that the exponent on our variable is an odd number, so this one would be no. Try D, E, and F. All right, so let's look at it. The first one should be yes, it is a difference. X squared is a perfect square, 16 is a perfect square, and y squared is a perfect square. The next one is also yes, it is a difference. 49x squared is a perfect square, and 4 is a perfect square. And the last one would be no, because it is not a difference. It doesn't matter if those terms are perfect squares. It is not a difference. Okay, so let's now go into factoring. Remember, the first thing we always want to look for is, does it have a greatest common factor? Is there something that both of these terms have in common other than 1? And for the first one, it's not. So the next step is, because it is a binomial, because it's only 2 terms, we ask ourselves, is this a difference of perfect squares? Yes, it's a difference, and both terms are perfect squares. So we create our 2 sets. In the front of each set, you're going to put the square root of the first term. So think about it. The square root of x squared is just x. So that's what's going to go in the front of each term. And then in the back of each term, you're going to put the square root of the last term. And we know that the square root of 16 is 4. So in the back of each one, we're going to put 4. And then one's going to be plus and one's going to be minus. And you can also think about it. When you FOIL or box to check, positive 4 times negative 4 is what's going to give you that negative 16 right there. So it wouldn't make sense for both of them to be minus or both of them to be plus, because that wouldn't give you that negative 16. Just like all problems, you can check this using FOIL or box or distributing back. So if I FOIL real quick, x times x gives us x squared. For our outside, x times negative 4 is negative 4x. Inside, positive 4 times x is positive 4x. And last, positive 4 times negative 4 is negative 16. And then we can see that these outer and inner terms cancel, which is why we don't have that middle term. And when we combine our like terms, we just have x squared minus 16, which was our original product. All right, let's try the next one. First, does it have a greatest common factor other than 1? No. Second, because it is a binomial, is it a difference of perfect squares? Yes. So we create our 2 sets. The square root of 4y squared is 2y. The square root of 81 is 9. And then you're going to make one of them positive and one of them negative. Remember, it does not matter the order you write those in. If you put 2y minus 9 and then 2y plus 9, it's the exact same answer. Again, you can always check it by boxing or foiling them back. All right, let's go to the third one. Does it have a greatest common factor? No. Is this a difference of perfect squares? Yes, because the a to the 4th, that is an even exponent. So we're going to create our sets. Okay, so what is the square root of a to the fourth? All you have to do is half that exponent. That would be a squared. Because remember, a squared times a squared is what would have given us a to the fourth. So in the front of each one, we're going to put a squared. One's going to be plus, one's going to be minus. What is the square root of 64? It is 8. And again, you can check it by boxing or foiling. All right, try number 4. When you're finished, start the video back. Okay, does this have a greatest common factor? No. Is it a difference of perfect squares? Yes. The square root of c squared is c. The square root of 25d squared is 5d. And then make one of them positive and one of them negative. And I switched it around this time because it doesn't matter. It doesn't matter what order the factors are in. All right, let's go to number 5. Number 5 is tricky because immediately we're like, oh yeah, that's a difference of squares. It's a difference and those are perfect squares. But remember, the first step is always to look and see, does it have a greatest common factor? And in this case, both these numbers are divisible by 9. 9 goes into 36 4 times, and 9 goes into 81 9 times. So we need to start by factoring that 9 out in front, which then leaves us with 4x squared minus 9y squared. And then this binomial we have left is still a difference of perfect squares. So we'll keep going. So the 9 is just going to float out in front. We're going to create our 2 sets of parentheses. The square root of 4x squared is 2x. The square root of 9y squared is 3y. And make one of them positive, one of them negative. All right, try the last one. And when you're finished, start back the video. Okay, so does this have a greatest common factor? That's the first thing we have to check for. Because if you go straight for looking for differences of squares, in this one you wouldn't think it's factorable because 2 is not a perfect square and 18 is not a perfect square. But in this case, 2 goes into both numbers and they also are both divisible by x. So the greatest common factor here is 2x. So what we're going to do is let that 2x come out in front. This is the very first lesson we did with all this factoring out the greatest common factor. And then if we divide 2x cubed by 2x, we are left with x squared. And then negative 18 divided by 2 is minus 9, and we already factored the x out. Now, is x squared minus 9 a difference of squares? Yes. So we have our 2x. We create our 2 sets of parentheses. The square root of x squared is x. The square root of 9 is 3. Make one positive and one negative. And that's our lesson on factoring binomials. Tomorrow, we're going to put all this together. We're going to do factoring binomials, trinomials, and 4 terms all mixed up. And I'll do a little review of each one with you in a lesson, and then you'll have some mixed practice.